Welcome back. In this final part of submodule 4.1 about the geological and hydrogeological parameters and conditions, we look at conditions that can actually pose risks on the use of groundwater heat exchangers. So, of course, certain geological or hydrogeological conditions are not the only issues that can limit the use of groundwater for heating and cooling, but that's not what we deal with here. So I want to point out that here we focus on anything that might pose a risk or limitation of use on the groundwater heat exchanger. The other way around, there are also certain situations where the groundwater heat exchanger might pose a risk on the environment, as we have just seen for the groundwater temperature, but this is not what we deal with here. Environmental considerations are covered in submodule 1.9. So first of all, you already know that to keep the groundwater quantity, it is the best solution to re-inject the groundwater back into the aquifer. In case of a low depth to the groundwater level, or when using a confined aquifer, this might be difficult or not possible at all. And in these cases, an alternative could be the discharge into a surface water or the sewage system. Well sanding can occur if pumping not only moves groundwater, but also sand into the well, which can decrease the pumping rate. And to avoid that, well construction has to be done very carefully. This includes choosing well pipes and grain size of the backfilling that match the aquifer material surrounding the well. Clogging can also occur in the injection well. This happens, for example, when oxygen-free water with high iron or manganese content gets in contact with air before it is returned to the aquifer. And in this case, you would get this orange-colored precipitation that you see here on the pictures in the injection well. Certain groundwater chemistry can also lead to corrosion of casings or the heat exchanger. This is the case if the water is highly mineralized. You can see the thresholds of these risks in this table. So check the groundwater chemistry before constructing your well. Choosing the right material and adequately constructing the whole system with as little air contact as possible can also help mitigating chemistry-related issues. And just as any other construction, also groundwater heat exchangers can get damaged via natural hazards, for example, landslides. Finally, I will go quickly through drilling hazards that you want to check for beforehand. They are actually similar to the ones when drilling for borehole heat exchangers. When drilling any borehole, one should be aware of any swellable or soluble rocks that might lead to unexpected changes of volume in the underground. Cavities in the underground due to karstification or mining processes can pose a drilling hazard. Same goes for the existing underground infrastructure. You definitely do not want to drill into any metro tunnels. Artesian or confined groundwater and shallow gas occurrences are the last drilling hazards to be mentioned here. With the right drilling equipment, damage, for example, because of uncontrollable water flow out of the well, can be avoided in these cases. If you're interested in more practical considerations for drillings, then please have a look into the other submodules 4.4 and 3.1. And now move on to the next submodule to learn more about the groundwater heat exchangers.